Today we're going to talk about the Mastervolt Alpha Pro III regulator. This device is a very specialized device, so we're going to talk all about it from installation, wiring, and configuration. It's got a lot of intelligence, so we want to make sure we do it right. This is what the Alpha Pro III looks like. When we install it, there is some tricks to the wiring, so I wanted to go through that first. I'm going to pull up a wiring diagram that we created for an Electromax alternator, but this will work for almost any alternator. The first thing you need to know is the Alpha Pro III regulator will only work with an N-type alternator. N is in Nancy, which means it's being switched on the negative side. It will not work on a P-type. Make sure that that is the very first thing you figure out. Most alternator manufacturers will publish that. And then if you have an existing alternator you want to use this for, you can take your alternator to a special alternator shop and they can usually convert it to an N-type. But just make sure that you figure that out first, or you're going to run into a world of trouble. So this is the Alpha Pro III, just a little gray box here. There's a lot going on in terms of what's connected to it, which is why I want to talk through it. First of all, it is a masterbus device. You can see the masterbus ports here. When you install it, after it's mounted, the first thing you want to do is you want to turn the potentiometer up here to face the M. The M means that you're going to configure it under masterbus. If you were going to use this in a standard starting application where the alternator is feeding the start battery that's also cranking, you can put it in the arrow up into 12 volt for a 12 volt system or down into a 24 volt. But any kind of custom configuration requires the potentiometer pointing at the letter M. Otherwise, it cannot be configured. So you want to turn that. That's what this video is about, is configuring it custom. After you go from there, we need to talk about wiring. So the easiest one, there's going to be 3/4 inch quick connects in the bottom middle of the regulator. Ground is on the far right. The field connection to the alternator is going to be in the middle. That is the field connection directly to the alternator. So there will most likely be a field stud on your alternator or a field terminal. That's where that wire is going to connect. Then the other connection is going to be the positive feed from your battery source to pulse that field. So that in this situation is going to be the same battery that we are charging, the house battery bus right here. So that way power passes through the regulator and is regulated on this field wire to adjust the alternator appropriately. So those are the main connections there. Note that this battery connection does not control the alternator being powered or the sense voltage. And that's a very important wire that a lot of people mess up. We'll get there in just a second. The next wire that's critical is this white wire, which is number 2 in the Molex connector. This is going to be your tach. So that's going to come out of whatever the tachometer connection is on your particular alternator. In an Electromax externally regulated alternator, that tach connection is on the rectifier portion out here, labeled W. And then the next one is the most important. This is both the on signal wire as well as the battery sense voltage wire. So this is the brown wire coming out of the Molex connector. It is doing a lot. So it is triggering the regulator to turn on and start charging, as well as sensing the battery voltage of the battery that is being charged, which is extremely important for the regulator to work properly. So we always recommend, because 99% of use cases for this regulator is charging a large house bank, that this brown sense wire be connected to the house bank. But since the house bank is always on in most vessels and vehicles, we use a relay. And that relay turns on from an ignition source, whether it's the key itself in the run position, or if it is like a fuel pump or something else that only turns on when the engine's actually turning and belts are running, that ignition will turn on like a normal square relay. That relay will connect power to the sense/on brown wire for the regulator to start. If you run this straight off the house battery, so it's constantly on, you will be electrifying the field coils inside your alternator and burn it up because it's not spinning, so it cannot cool itself. So that's bad. The other problem we see is if you have an ignition that's a 12 volt, but you have a 24 volt house bank, you'll essentially be sensing 12 volts off ignition, but trying to charge a 24-volt bank, and the regulator will try to ramp up to charge it really quickly, and then you'll have issues there. So we always recommend, and this is also in the manual, put an external relay here. Ignition controls the relay. Relay turns on the sense slash power wire for the regulator. So that is an overview of the wiring. You can find this diagram on our website under the Electromax alternators themselves. Now we're going to go into programming. So again, this is a masterbus device. You can see it's connected to masterbus in this diagram. Once we connect into masterbus, which you can click our link to learn more about masterbus, you're going to have all the devices in the network. We need to log into the network by right-clicking on the USB interface in the top and going to log in. We're going to use our password, 498. I'm going to log in here. You can see all the devices loading. This system has 2 alternator regulators. It has a couple of batteries that have been clustered. It has a combi master, has the display, has a NEMA adapter, and it has a Mac Plus DC to DC charger. We're just going to talk about the regulators today. So let's go to the first one. If this is the very first time you're going to be waking up your regulator, it's going to look slightly different than this because this has already been configured. So we're going to go into the monitoring page, and it'll usually ask to unlock in this page to do some kind of setup. As you can see, we're off right now, and we're in standby because the engine isn't running. We're going to turn that engine on shortly. The alarms page, nothing is here right now because nothing is alarming, but you can see that there. History tells you everything that's run, the runtime, and then we're going to spend most of our time here in configuration. So first and foremost, in order to configure the regulator, it's one of the only devices where you have to unlock the setup. And the reason for that is if your engine is running, we do not want to make changes to a live alternator. So by unlocking it, we stop energizing the field coils, and you can actually configure this device while the engine's on. Then you can lock it, and then it'll engage the alternator, and you can see if your settings were appropriate. So starting at the top left, we have language. We have the name of the device. This is going to be port alternator. We always like to keep masterbus power on. So we always do that for any device that can power it. This is a powering device, so we're going to put that on here. Startup delay is defaulted to 10 seconds. I like to leave it there. Alternator type, you can pick Mastervolt alternators that they sell. This boat is using an Electromax alternator, so we're using user defined, which is going to be in a lot of cases. Battery voltage is 12 volts in this system. Temp sensor, you have a choice between the battery temp sensor and alternator temp sensor. Strongly recommend using the alternator temp sensor, which is a separate part number that we have on our website. It's only like $15, and it's going to save your alternator in the long run because it will temperature compensate. So we want to use the alternator temp sensor whenever possible. This temperature range is going to be the range that we're going to reduce the output of the alternator in order to prevent it from going over temperature. So this is going to be based on your alternator manufacturer's recommendations. Use their recommendations for when you should be reducing and when you should not be charging at all. So these were set based on Electromax recommendations for this alternator. This is a 12 volt 160 amp alternator. Alternator maximum output. So this allows you to control how much of that rating from the manufacturer you're going to be able to get. I never like to push alternators to 100%. I would much rather use a larger alternator and regulate it down. This is just for longevity. You know, having alternator problems in the middle of the ocean or while you're driving is horrible. So we don't want to induce that by maxing it out. So I like to put it at 80 or 90%. This boat has 2 alternators, so there's a lot of power, so we're just going to go with 80% today. Then we have to do pole pairs. Pole pairs is a very important function. Most people do not know the pole pairs in their alternator. So you have to go to the manufacturer's website or call them to get the pole pairs. And what will actually happen is they will know the amount of poles in the alternator. And so this alternator has 12 poles, which is published by the manufacturer, but Mastervolt uses pole pairs. So you take the poles in the alternator, divide it in half, and that's the number that you would need to input here. The good news is this is almost always somewhere between 4 and 8. So you can kind of guess and check, and we'll show you how that looks in a little bit. Pulley ratio. This is also an important number. So this is the It's the diameter of the crankshaft pulley divided by the diameter of the alternator pulley. Mostly going to be in the 2, 3, or 4 range. So let's say you had a crankshaft pulley of 8 and a alternator pulley of 4. 8 divided by 4 would be 2, and that would be your pulley ratio. This we can actually do math to get perfectly accurate, and I'll show you how to do that in a second. Keep alive percentage. This is like the percentage in order to keep the alternator running based on how low it's outputting. Alternator event. Don't recommend you actually use this. It's a very rare use case, but this allows you at this RPM that you define to create an event in the events tab to trigger something else. So like, let's say you wanted to turn on the inverter only when the alternator was at 900 RPMs or above or something, you could do that here. Or we've been in one vessel, we wanted to turn off chargers because the alternators were so large when that boat got over 1200 RPM. And so we would use this event to turn off chargers. But in most of the cases, you're not using this. So it's not a big deal. If you have a small engine or you're actually worried about stalling it at startup because the alternator puts so much load on the crankshaft, you can click this box and then you can actually say we want to only do 20% of the alternator's power below this RPM, and then we want to do 100% above this RPM. And so that would matter if you're doing like 100 horsepower or less engines, small diesel inboard engines for sailboats. This could be a good use case, but in larger engines, this really doesn't matter because you're not going to worry about stalling. The type of battery that you're going to be charging. So this boat has MLI, so this is going to be MLIs here, but of course you could be using AGM or flooded or gel as well. Because we picked MLI, all of the bulk, absorb, and float voltages have been predefined for us, so we don't need to set anything there. Same with the alarm settings, we don't need to set anything there. Those are defined by the battery voltage, by the battery type. Low field current, you can decide if you want this alarm to exist or not in terms of just notifying you. We like to suppress it because sometimes there's a low field current because the batteries are charged. And that's just the regulator doing its job. So we don't want a situation where someone's getting an alarm just because their boat's functioning properly. So we like to suppress this alarm. And then the next thing you want to do is if you have a Mastervolt based shunt, what you can do is you can actually try to select that shunt. And now the regulator will use the shunt as the device that it decides on how to charge as opposed to the battery's voltage. So if you had a master shunt, you could do that as well. And then you have your processor versions. These regulators actually need a firmware update, which we could do. And you go back to the factory settings. And again, you have to lock this in order to actually engage it. If you did all that configuration and just left the screen, the regulator would not work because the setup is not locked. So what we're going to do is we're going to actually start up the engines and come back. And then we're going to show you what that looks like. All right, so we've turned the engine on. We've just turned the port alternator on, and now we're going to configure that alternator live and show you what that looks like. So port alternator, remember we got to log in, 498. Coming over here. This device is off even though the engine is running, and that's because we unlocked the setups. You can tell you're unlocked because the word lock is here. If you were locked, it would say unlock. So we're just going to go back through this. So startup delay 10 seconds is good. This is a 12 volt system. We like to do 80% output, 80 or 90. Our temp sensing is on the alternator. So that's where we have the actual sensing unit. The voltage or the reduction based on the alternator's temperature from the manufacturer is here. Enable RPM is checked. This helps give you really accurate RPM information. So we've checked that box. We know that we have 12 poles in this alternator, which is published by the alternator manufacturer. So that means we have 6 pole pairs. Now we need to do pulley ratio. And so that's one where you can either measure the pulley ratio by measuring the crankshaft and dividing it by the pulley alternator diameter, but you can also do math here. And I like to do that because it's really, really accurate. And so I like to just put the number 2 in here, and then we're going to do math to find the exact pulley ratio, knowing that this constant 2 is not the real number, but it's a good starting point. Keep alive 6%, alternate RPM event, we're not using that. Lithium ion battery is going to be what we select. that defaults our bulk, absorption, float voltages, as well as our alarms. We like to suppress the field current alarm because we don't care if the field current's low, because that may mean the battery is just fully charged. And then we do want to select a Mastervolt shunt if possible. So we can select, there's 2 shunts in this, 1 per MLI battery. So we have the house and the house port, and then the house bat. Because these are clustered, you can see they're clustered up here in Master Adjust. House bat is the primary, house port is the secondary. So we want to look at the cluster primary. So that's house bat. House bat. So this is a live system, so it's going to blink like that when you make changes. We're going to start float state of charge at, I'm going to do 99% here. So that means it's actually going to go into float voltage when these batteries hit 99% instead of 100. And then we're going to return absorption return amps. That means anything in the 18 amp range or lower is going to be considered triggering for going into absorption. Minimum absorption time of 15 minutes is fine. And then if you wanted to deselect the shunt, you can do that here. So we're going to see how our configuration went. Again, if you go to the monitoring page, the regulator is off. So now we're going to lock it. Locally, you're going to hear the alternator actually turn on, and the harmonics of the engine will change because you're loading it up and putting pressure on the belts. So it takes about 10-15 seconds. You can see now we've clicked on charging. We're in float because this battery is charged at the dock right now. Battery voltage, battery temperature, alternator voltage. You can see it's essentially identical, so that's a really good sign. Sense voltage, essentially identical, very good sign. If this sense voltage is wildly different, it most likely means the sense wire was not wired correctly and probably needs a relay. So that's a really good sign that there's an issue. But here you can see sense voltage is very similar to battery voltage, so we're good. Field current, the lower the number here, the less the amps being pushed out of the alternator. The higher the number, the more the amps. And so this can go up to, I believe, 20 amps of field. So 1 is very low, but again, the batteries are full. Alternator temperature, this is right off the case of the alternator. We're sitting at the dock at idle, so this is not going to get super hot. Alternator shaft RPM, that's literally the alternator shaft. That's not the engine shaft. So this is going to be a very high number because it's a multiple of the engine's RPM. So now here is where we're going to do some math. So the engine shaft is not spinning at 820 RPMs. It's actually spinning at about 685. And so that's because we put in a random number in the pulley ratio. So we need to do some math here. So we'll put this equation right here on the video. But the equation is you want the RPM that you see here, which I'm going to call the regulator's RPM, so 822. You want to divide that by X, which is our variable pulley ratio that we're trying to find out. And then that's going to equal the real engine RPM, which you're going to pull off the engine kind of helm information. And then you're going to divide that by 2, which is the number that we arbitrarily put in. And so now you're going to do math, and you're going to come out with trying to solve for X. And that's going to equal 2.35 for this particular vessel. And so we're going to go back to configuration. We're going to unlock it, which will turn off the regulator. You'll hear harmonics change, and we're going to change the pulley ratio to 2.35. Then we're going to lock the setup, go back to monitoring, give it about 10 seconds to turn on. Once we see it turn on, we're going to see a different RPM here. And we want this RPM to match what the engine RPM is on the engine display. And so we can see that now we're right in that 690-ish range. And so we're going to call that accurate. And of course, it's going to be the same pulley ratio on the other engine because they should have identical brackets and pulleys and belts. So that's a really nice way, without getting on your hands and knees, to figure out the pulley ratio. Final things to look at: shunt is connected in this situation. State of charge is 100. So we're using the shunt information to actually charge this battery instead of purely voltage, which is much more accurate, because if current is coming out of the battery, the regulator is going to see that and know that the battery is at 100%, but it needs some power to power loads. So it will just give power as a power supply instead of at charging levels. So that's a really good aspect of being able to use Mastervolt devices connected together to optimize the system. And so that is the regulator. I want to just go one step further and show you, if you do have Mastervolt batteries in a system, you need to set special events for the regulator. So we're going to go to one of these MLIs, and you can see we have stop charges for the Combi Master. We have battery safety, where the battery will open its relay, and you can watch our configuring a battery page. But for specifically the regulator, you can see we need to set stop charges. So you need a stop charge for each battery to target each regulator. And when it turns on stop charge command, you need to copy that command. So essentially, stop charge is triggered by the battery. It targets the appropriate regulator. It's going to target the stop charge portion of the regulator and execute that command with the word copy. So we're doing that for the port alternator. We're doing that for the starboard alternator. Is where we're going to do that. You're going to need to replicate these commands on the other MLIs in the system. The other thing we're going to do is, if there's a battery safety, we're going to do the same command. So we're going to go to the port alternator, and we are going to go to stop charge, and we are going to copy. So if there's a battery safety or a stop charge signal thrown by the battery, we're going to turn off these regulators so that we don't accidentally charge when the battery is either in safety or in a stop charge signal. So that's really important, because you never want an alternator to be charging when there is no battery there. And in a battery safety, the relay is open, and therefore the battery is not there to be charged. So you can damage your alternator. So this allows you to protect your alternator and also protect your battery at the same time. So again, we've got stop charges for both alternators and battery safeties for both alternators. And you want to do that for every single MLI in the boat. And that is how you configure a Mastervolt Alpha Pro III alternator regulator. Thank you.
To learn more, give us a call.